How can you continue to see the world as real if the self that is determining it to be real is intangible?
We create reality, or reality-producing machines.
There is no out there, independent of what's going on in here. What I thought was unreal now, for me, seems in some ways to be more real than what I think to be real, which seems now more to be unreal.
You can't explain it. And anybody who gets too lost and anybody who spends too much time trying to explain it is likely to get lost forever down the rabbit hole of mysteriousness.
I think the more you look at quantum physics, the more mysterious and wondrous it becomes.
But I think if you take quantum mechanics seriously enough, it puts the responsibility squarely in your lap, and it doesn't give answers that are clear-cut and comforting. It says, yes, the world is a very big place. It's very mysterious. Mechanism is not the answer, but I'm not going to tell you what the answer is.
Asking yourself these deeper questions opens up new ways of being in the world. It brings in a breath of fresh air. It makes life more joyful. The real trick to life is not to be in the know, but be in the mystery.
Quantum physics, in very succinctly speaking, is a physics of possibilities.
These are questions. These are addressing questions of how the world feels to us, of whether there's a difference between the way the world feels to us and the way it really is.
First of all, let's talk about the subatomic world, and then we'll talk about what it's telling us about reality. The first thing I want to tell you about the subatomic world is it's totally a fantasy created by mad physicists trying to figure out what the heck is going on when they do these little experiments. By little experiments, I mean big energy in little spaces and little pieces of time. It gets pretty nutty at that realm of things, and so subatomic physics was invented to try to figure that all out. We need a new science down there. It's called quantum physics, and it is subject to a whole range of debatable hypotheses, thoughts, feelings, intuitions as to what the heck is really going on.
Matter is not what we have long thought it to be. To the scientist, matter has always been thought of as sort of the ultimate in that which is static and predictable.
Within all the atoms and molecules, all the space within them, the particles take up an insignificant amount of the volume of an atom or molecule, the fundamental particles. The rest of it is vacuum.
What seems to happen is that particles appear and disappear all the time. So where do they go when they're not here? Now, that question is tricky. I'm going to give you two answers. Answer number one. They go into an alternative universe where the people in that universe are asking the same question about those particles when they come into our universe. They say, where do they go?
In fact, the universe is mostly empty.
We like to think of space as empty and matter as solid. But in fact, there is essentially nothing to matter whatsoever. It's completely insubstantial. Take a look at an atom. We think of it as a kind of hard ball. Then we say, oh, well, no, not really. It's this little tiny point of really dense matter right at the center, surrounded by a kind of fluffy probability cloud of electrons popping in and out of existence. But then it turns out that that's not even right. Even the nucleus, which we think of as so dense, pops in and out of existence just as readily as the electrons do. The most solid thing you can say about all this insubstantial matter is that it's more like a thought. It's like a concentrated bit of information.
When you ain't looking, it's like a wave When you are looking, it's like a particle.
When you are not looking, there are waves of possibility. When you are looking, then there are particles of experience.
A particle, which we think of as a solid thing, really exists in a so-called superposition, a spread out wave of possible locations. And it's in all of those at once. The instant you check on it, it snaps into just one of those possible positions.
Quantum superposition implies that a particle can be in two or more places or states simultaneously. And this is a very bizarre concept and one of the hallmarks of the quantum world. How can a system or an object be in two or more states at the same time?
It's very easy. Instead of thinking of things as things, we all have a habit of thinking that everything around us is already a thing, existing without my input, without my choice. You have to banish that kind of thinking. Instead, you really have to recognize that even the material world around us, the chairs, the tables, the rooms, the carpet, camera included, all of these are nothing but possible movements of consciousness.
There's a physical reality that is absolutely rock solid, and yet it only, if you want to put it this way, it only comes into existence when it bumps up against some other piece of physical reality. That other piece may be us, and of course we're partial to those moments, but it doesn't have to be either. It could be just some incidental rock comes flying along and interacts with this fuzzy mass of stuff, and sure enough, it provokes it into a particular state of existence.
This is the only radical thinking that you need to do. But it is so radical, it's so difficult, because our tendency is that the world is already out there, independent of my experience. It is not. Quantum physics has been so clear about it. Heisenberg himself, co-discoverer of quantum physics, said atoms are not things. They are only tendencies. So instead of thinking of things, you have to think of possibilities. They're all possibilities of consciousness.
You now can see in numerous labs around the United States objects that are large enough to be seen by the naked eye, and they are in two places simultaneously. And you can actually take a photograph of that. Now, I suppose if you showed a photograph, they'd say, oh, great, here's this nice blob of colored light, and I see there's a bit of it over here and another bit of it. So you got a picture of two dots. What's the big deal? And if so, well, look right in the chamber. You can see it. We go, oh, I see two things there. You say, no, that's not two things. That's one thing. It's the same thing in two places. I'm not sure that people's jaw would drop about it, because I don't think people really believe it. And I don't mean that people say, oh, you're lying, or, oh, the scientists are confused. I think it is so mysterious that you can't even understand how amazing it is. And then furthermore, you've seen Star Trek and whatnot. Beam me up, Scotty. So it all seems sort of, oh, well, what does that really mean? But you've got to really stop and think about what that means, that it's the same object and it's in two places at once.